parallel plates, we have seen one expression, delta u by delta y is equal to minus 1 by 2 mu delta p by delta x into t minus 2y. Just in brief, I will tell you this delta p by delta x and delta u by delta y has relation between with each other. So delta p by delta x is pressure gradient, delta u by delta y is the velocity gradient. So now we know that if delta p by delta x is less than 0, that it is the negative pressure gradient, then the condition is a favorable pressure, condition for the boundary layer. Okay. So boundary layer remains attached to the surface. But if delta p by delta x becomes greater than 0, then the condition becomes unfavorable. And if delta p by delta x is equal to 0, then that is the point of separation. From that point, the boundary layer is about to detach or it is about to separate. So in the above expression, the thickness T is infinite as there is only one bottom plate and no other plate, as we have seen from Newton's law of viscosity. Okay. So let us take this thickness T as infinite, or we don't know the other end. So that's why this T minus 2y, this is a positive term, and from the expression, if T minus 2y is positive, then delta u by delta y is inversely varying with delta p by delta x. So if delta p by delta x is positive, delta u by delta y will be negative. If delta u by delta y is positive, delta p by delta x will be negative, and vice versa. Why I am telling this? Because the conditions for separation of boundary layer are more related to the velocity variation than the pressure gradient or the pressure variation. Because we have seen the velocity profile and we know the equation for velocity. So in the three conditions for separation of boundary layer, that if delta p by delta x is less than 0 or delta u by delta y is greater than 0 at mentioning at y is equal to 0, because when you integrate the equation delta u by delta y, or when you solve for delta u by delta, when you differentiate the velocity profile, then you have to find the value at y is equal to 0, that is near to the solid point. Okay, what is the condition? So if at that condition, if the delta u by delta y is coming greater than 0, then the boundary layer is not separated. If delta u by delta y is equal to 0, at y is equal to 0, or delta p by delta x is equal to 0, then the boundary layer is about to separate. It is at the point S. So it is, after that it is going to detach. And if delta u by delta y for the given profile, velocity profile, is less than 0, at y is equal to 0, or delta p by delta x is greater than 0, the boundary layer gets separated, which is not a favorable condition. So we should find delta u by delta y from the given velocity profile and calculate it, check it whether it is coming less than 0, greater than 0, or equal to 0. Remember, if delta u by delta y is greater than 0, it is a favorable condition. If delta u by delta y is equal to 0, it is about to separate. And if delta u by delta y is negative or less than 0, then the boundary layer is going to separate. It is not desirable condition, or it is called as an adverse condition. So let us take one numerical on separation of boundary layer, and that is the end of the unit number 6. So in this numerical, we have to just test whether the boundary layer is going to detach, or it is going to attach, or it is going to be on the point of separation. So let us see the numerical. For the following velocity profiles, determine whether the flow has separated or on the verge of separation or will attach with the surface. So there are three velocity profiles given. First, it is given small u upon capital U is equal to 3 by 2 y by delta minus 1 by 2 y by delta bracket cube. Second is u by capital U is equal to 2 into y by delta square minus y by delta cube. And third, u by capital U is equal to minus 2 into y by delta plus y by delta bracket square. So again, this is very simple. Just you have to see the velocity profile, take the velocity u in terms of the capital velocity u and y and delta. So here, if you see the first case, u is equal to small u is equal to 3u by 2 into y by delta minus u by 2 into y by delta q. If you take the derivative of u, partial derivative of u with respect to y, then if you solve it, take the differentiation with respect to y, then you will get the answer as dA by u by dA by y is equal to 3u by 2 delta minus 3u by 2 into y by delta square. And if you put y is equal to 0, that is dA by u by dA by y at y is equal to 0, you will get the answer 3u by 2 delta, and which is coming positive. The sign is positive, hence the flow will not separate. So if dA by u by dA by y is positive, flow will not separate. That already we have seen. So the boundary layer will remain attached with the surface, and that is the favorable condition. So this velocity profile is a good profile which should be followed. Second velocity profile, it is u by capital U is equal to 2 into y by delta bracket square minus y by delta bracket cube. If you solve again for u, dA by u by dA by y, and put the value of y equal to 0 inside that differentiation, then the answer at y is equal to 0, it is coming 0, and just that is the condition of the point of separation. So the flow is about to separate, it is on the verge of separation. So the second case, it is nothing but the boundary layer is about to separate. Okay, so from this onwards, the boundary layer will detach. Okay, so it is acceptable condition under certain circumstances. But the third profile is showing you that the value of dA by u by dA by y at y is equal to 0 is coming minus 2u upon delta, which is negative 1, and this negative sign shows that the flow has separated and it is not a favorable condition. So this velocity profile should not be preferred as the boundary layer is detached from the surface. So friends, this is about the separation of the boundary layer. Now I have already told you that the separation of the boundary layer is not favorable condition. So we have to avoid the separation of boundary layer. So there are some methods for avoiding the separation of boundary layer. So what are the methods that I have mentioned here? Because the separation, why separation is not required? If there is a separation, then you will see that there is a backflow and eddies are continuously formed in the region, and that disturbs the motion of the solid body, and hence continuous loss of energy also takes place. This separation of boundary layer is undesired, and hence attempts should be made to avoid the separation of this boundary layer by various methods. Which are that methods? So these are some of the methods that you have to try such that the boundary layer should remain attached to the solid body. So what are the possible ways? Let us provide some slot inside the solid body only, so that this fluid will get sucked inside that slot and it will not detach from the surface. Let us supply some additional energy from some external device, from blower, and it will force that air on the to remain attached to the solid surface. Let us supply some provide some bypass or the slotted wing to that solid body, so that it will turn that fluid to the attached to the surface. Many such methods are there. Just you provide some smooth surface or guiding surface to that solid surface, so that it will guide the flow along that side. So guide blades are also used in some surfaces like bend or elbow. Sharp edges are detaching the boundary layer. So you have to use a smooth or curved guiding blades. So that's why nowadays the shape of the vehicles or aeroplane, it is a streamlined shape because of the attachment of the boundary layer along the streamline or the what we can call it as aerofoil shape that is used, because the boundary layer remains attached to that aerofoil shape. That's why that shape has come into what you can say, come into use nowadays for the aeroplanes and for all the vehicles also. So friends, this is about unit number 6. I hope you have understood the main points about this unit, and I'll suggest you that you just go through the numericals, okay, based on the boundary layer thickness, displacement thickness, momentum thickness, energy thickness, as well as lift and drag, and the boundary layer separation. Very simple numericals, nothing in that. One numerical is coming there in the exam for at least 9 to 10 marks. So don't miss this chance to solve that numerical as well as theory. Already I have explained you much about the theory. Just go through the books for better clarification. So I hope you have understood this unit. Best of luck. Stay home. Stay safe. Thank you. Thank you very much.